Jai Hind and welcome everyone. Today's topic is real numbers. In simple terms, we can understand what are real numbers is. Real numbers consist of all the rational and irrational numbers. What are rational and irrational numbers? This we have discussed in our previous class. So rational numbers are those numbers which we can write in the form of p by q, where q is not equals to 0. And we can also say that natural numbers, whole numbers, integers, all, if we combine all these numbers and if we put all these numbers in a bag, and then we can name that bag as rationals. So we can say rational numbers includes all the numbers, whereas irrational numbers are those numbers which we cannot write in the form of p by q. It means what? Irrational numbers are those numbers which are in the form of like this, root 2, root 3, you can say, all numbers like this, right? More example we can write. Suppose we can say 0.12314 and so on. So these types of numbers are called irrational numbers. Now our next topic is Euclid division lemma. To understand Euclid's division lemma, first we have to understand what is lemma. So what is lemma? So to understand what is lemma, see, lemma is what? Lemma is a proven statement used for proving another statement. You have heard about so many statements. One, I'm going to write for you. So here I'm going to write. So see, in our childhood we have done so many sums of division, and whenever teacher asked us to just check your sum, we applied a formula. That formula is also known as division algorithm. That was what? Dividend is equals to divisor multiply quotient plus remainder, right? A Greek mathematician, Euclid, used this method to find the HCF of two positive integers. He used this formula for that. How he used it? So that is in this, that is called Euclid's division lemma. So what he did, he suggests that suppose we are having two positive integers, one is a, one is b, and if I am going to divide a by b, then a will be dividend, this a will be dividend, and then this b will be divisor. So whenever we divide two positive integers, we will have two more positive integers. One will be quotient and one will be remainder. Suppose the quotient is q and the remainder is r. So a will be equals to what? bq plus r. So you can see here a, that is dividend, equals to b multiply q. B is divisor, q is quotient. So divisor multiply quotient plus remainder. Now here what we have a relation between this b and r. What is that relation? That is r will be always less than b, and it can be greater than or equals to 0, isn't it? When you divide two numbers, suppose a is greater number, b is smaller number, and when you will divide, the remainder can be 0, it can be more than 0, but it will be always less than the divisor. Less than divisor. So this is called Euclid's division lemma. So whenever we have to remember this Euclid's division lemma, that is a is equals to bq plus r, where a and b are two positive integers. Okay, when we divide two positive integers, we will have two more positive integers. One will be q, one will be r. Then we have a relation between the divisor and the remainder. The divisor and the remainder. What is the relation? The remainder will be always less than the divisor, and it can be 0 or more than 0. So this is what Euclid's division lemma. Now what is the application of this Euclid's division lemma? It is used to find the HCF of two or more than two positive integers. How? Let us see by example. So let us say we are going to find HCF of 225 and 135. 225 and 135. So obviously 225 is greater and 135 is the smaller one. So we can write 225 is the dividend and 135 is divisor. So when you will divide 225 by 135, so divide it, 135 1 ja 135, and you will write the remainder. So this form, this same pattern we have written in this form, that is dividend, that is 225, divisor 135, and then the quotient, and then the remainder. Right? What I said? Dividend 135 is the divisor, 1 is the quotient, and 90 is the remainder. Okay, right? So now we have to repeat this same procedure till we will not have the remainder 0. So we have to repeat this same procedure, this same step. Okay, now so our first step is we have done, that is 225 is our dividend, 135 is our divisor, multiply, 1 is our quotient, and 90 is our remainder. Right? Now to repeat this step once again, we need what? We need dividend and we need divisor. Now how to get that? Now see, the divisor in first line, that is 135, will make it dividend, and the remainder in the first step will make divisor. Okay, got it? Once again I am going to repeat. The divisor in the first step will make dividend for the second step, and the remainder in the first step will make divisor in the second step. And again we'll 90 multiply by what? 90 1 is 90 and plus 45 plus 45 is what? 135. Right? Now here 135 is the dividend, 90 is the divisor, 1 is the quotient, and 45 is the remainder. So we have to repeat this step again and again till in the remainder 0 will be not there. Okay, then for third step, you see, for the third step you tell me what will be the dividend. So the second step was what? 135 equals to 90 multiply 1 plus 45. So as we have done in previously, the divisor of the previous step will be our dividend, right? And the remainder of that step will be our divisor. And then 45 multiplied 2. Okay, 45 multiplied 2 is 90 and plus remainder will be 9. Okay, sorry, remainder will be 0. Here 0 is here. This is 90. This is 90. So here is 0. Now you can see in this step our dividend is 90. Our dividend is 90. Our divisor is 45. Our quotient is 2 and our remainder is 0. As you will get the remainder 0, it means your sum is finished and you are able to write the SCF of the numbers. Now what will be the SCF? The SCF will be the divisor of that step where remainder is 0. In this case, we can see in this step we are having the remainder is 0. As the remainder is 0, so from this step we can see our SCF is what? What is divisor? 45. So our SCF is 45. So SCF is what? That is 45. So this is how we can find the SCF of two positive integers by Euclid division algorithm. Okay, now previously I have said Euclid division lemma. What was lemma? Lemma was what? Lemma is a proven statement which is used for proving another statement. Now what I am saying, whenever we will find SCF of two positive integers, we will use Euclid's division algorithm. What will use? We'll use Euclid's division algorithm. Now what is algorithm? See, in simple terms we can say algorithm is the repetition of a step again and again. Okay, right? So what is algorithm? It is a repetition of any step, right? That is called algorithm. So you can see here algorithm, Euclid's division algorithm. That is, an algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. Okay, so when we repeat a step again and again to find any solution, that procedure is called algorithm. So hopefully you will be understood how we have to find the SCF of two positive integers by Euclid's division algorithm. Okay, right? So